Here's a quick review for the quiz next class. So first is this section that said for each angle give the equivalent angle, so it has to be between 0 and 360. So if it's bigger than 360, like 510, you're going to do minus 360. 510 minus 360 is 150 degrees. So it asks in B, tell which quadrant it's in. That would mean it is in, if I look here, I'll draw this. This is quadrant 1, that's 0 to 90. Quadrant 2 is 90 to 180. Quadrant 3, 180 to 270. And quadrant 4 is 270 to 360. So 150 is between 90 and 180. Therefore, it is in quadrant 2. 13 pi over 3. Now, since it's in radians already, I can just subtract 2 pi, right? And that's 2 pi over 1. Well, in order to subtract fractions, they have to have a common denominator, right? So this would have to end up being multiply by 3 and 3. It would be 3 is the denominator, and then 13 pi minus 6 pi, is 7 pi. Which is still more than 2 pi, because that's one full time around, so you'd have to subtract 2 pi again. So then you have 7 pi minus 6 pi is just pi over 3. Now pi over 3, if you look at your unit circle, is in quadrant 1. Okay? Some of us didn't like doing radians at all, so you would have to, I'll redo that one then, you would have to convert this to degrees, which you're going to do by doing 180 over pi. Your pi's cancel. 13 times 180 is 2,340, and then I have a 3 on bottom, so divide by 3. Now you get 780, right? So you would have to do 780 minus 360 gives you 420. And then minus 360 again gives you 60 degrees, which now that number is between 0 and 360, and it still yields us to say it is going to fall in quadrant 1. So either way works. Just make sure you keep going until it is between 0 and 360. You can tell which quadrant it lies in. Okay, if we look at the next kind of problem, they give us the point 5, 12. Well, 5 is my x value, 12 is my y. So that's going to put me, since they're both positive, that's going to put me in quadrant 1. We'll say 5, this is 12, right? So to the right 5, up 12. That's my triangle right there, 5, 12. Use the Pythagorean theorem, so 5 squared plus 12 squared equals, we'll just call this c squared. 5 squared is 25. 12 squared is 144. So 169 equals c squared. Square root, c equals 13. So in the hypotenuse, I'm going to put 13. Now you're ready to write your ratio. So you're always standing here at the origin, okay? Sine, remember, is opposite over hypotenuse. So opposite, let me change colors here for you. Opposite of the theta is over here. Adjacent is right next to it here. Across from the 90 is always the hypotenuse. So if I want opposite over hypotenuse, then I say, okay, what's in the opposite side? 12. What's the hypotenuse? 13. Cosine is adjacent over hypotenuse. So I labeled over there. Adjacent is 5. Hypotenuse is 13. Tangent is opposite over adjacent. So opposite is 12. Adjacent is 5. Done. Don't try to reduce the fraction. Don't rewrite it as a decimal. Don't rewrite it as a mixed number. Leave it as a ratio. You're done. Okay, on, this side here, they're giving me a reference angle, and they want me to draw that special triangle and then find these ratios, right? So first thing I would do is draw my coordinate plane. And then I've got the terminal side goes this way. 225 degrees. It's going to be in quadrant 3, right? Because this is 0, 90, 180, 270, and then back to 360, right? So I'm starting here. I'm coming around, I don't know, maybe to like here. Okay, so we'll say that's 225 degrees. Remember, you're drawing a triangle always so that it's perpendicular to the x-axis. Okay, so if I came around, now this is 225. What is the distance between, I'm going to just move that because that was kind of in my way, from 225 to 180? Well, so to get that, I'm just doing 225 minus 180, right? So that angle is 45, right? So if that's a 45, that means this is 45 also, which means the sides are x, x, and x root 2, just our special triangles here, okay? So now I'm ready to find sine 225, cosine 225, and cotangent 225. I'm running out of space here. Sine is opposite over hypotenuse. Now, keep in mind, in quadrant 3, you went to the left, so that's negative, and you went down, so that one's also negative, okay? And I guess I should also label my sides, right? So this is where you're standing, so this is adjacent, this is opposite, and this one's across from the 90, so this one's always your hypotenuse. So sine is opposite, which is negative x, over hypotenuse, which is x root 2. Well, I know the x's cancel, so it's negative 1 over root 2. Multiply top and bottom by root 2. So it becomes negative root 2 over 2. All right. Cosine is adjacent, which again is negative x over hypotenuse, which again is root 2. Well, your x's cancel. So it's actually the exact same thing, right? Because everything else is going to be the same. Cotangent is the reciprocal of tan, which is opposite over adjacent. So cotan is going to be adjacent over opposite, which order actually doesn't really matter for that. No matter what, we should get 1. Okay? All right. Moving on to the next one. I drew that one too big, so I'm going to have to squeeze this one in up here. 330 degrees. If we start in the 0 direction, we have to come all the way around. This is 270. This is 360, right? So we're coming all the way around until we get to 330. Well, if I draw that perpendicular line up to the y-axis, x-axis, and find the difference between 360 and 330, that means this angle here is 30. Okay? If that angle is 30, then the side across from it is x, the side adjacent to it is my long leg, x root 3, and the hypotenuse is 2 times the short leg, right? This might be the hardest part for you, is remembering those special triangles. Now you have to set up your ratio. So this is where I'm standing, so this is opposite, this is adjacent, and this is your hypotenuse, okay? So if I want sine, let's go back to my red. If I want sine 330, sine is opposite over hypotenuse. What is opposite? X. What is the hypotenuse? 2x. So those cancel. You're just left with 1/2. Check on your calculator. If it's in degree, you should be able to do sine 330 and get 1/2. Except that, what did I forget? Your x is positive, your y is negative. So really, it was negative x, which means it's negative 1/2. I just checked it on my calculator and saw that, right? All right, cosine 330. So cosine is adjacent, which is x root 3, over hypotenuse, which is 2x. These cancel, it's just root 3 over 2. So if you do cosine 330 in your calculator, you get 0.866025438, right? So then I check and I say, was that the same thing as root 3 over 2? Hey, it is. So I know I did that one correctly, right? Check your answers and you'll feel a lot better about it. Cotangent, adjacent, x root 3 over opposite, negative x. These cancel, so it should just be negative root 3. I don't have a button for cotangent, but to check on the calculator, I would do 1 divided by tan 330. And I get negative 1.732050808. And I say, is that the same thing as negative root 3? Oh, it is. Check, did that one correctly. Okay. Okay, then we're on to the unit circle. Now, this is the shortcut for remembering, like, in which quadrants they are positive. So, but you could always just check it, right? Because you're like, okay, here, your x is positive and your y is positive. Here, your x is negative, but your y is positive. Your x is negative, whoops, and your y is negative. And then here, your x is positive and your y is negative. So, and you're like, okay, I know cosine is always negative, but you could just think them through too, or memorize. All sines, tan, and cosine. Okay, so they're all positive in quadrant 1, but only sine is going to be positive because cosine has x in it and tan has x, and that's negative. And then only tan is positive here because a negative and a negative is positive. So to answer the questions, oh, and remember it starts 1, 2, 3, 4. Okay, so quadrant blank, sine is positive. Here sine is positive, right? So that is quadrant 2. The next one, I don't like the way that 2 turned out. All are positive. Well, all are positive. That is quadrant 1. Cosine is positive in quadrant 4, and tan is positive in quadrant 3. Okay? Draw the picture, memorize it. Doesn't matter to me as long as you can do it. Okay. For this next section, it's going to be kind of a review of what we did on the first page. We're just finding the equivalent angle. Okay, so if it's less than 360, if it's negative, we're going to add 360. So that puts us at 300 degrees, which again, if you look at your quadrant, that puts us in quadrant 4 because this was 0, 90, 180, 270, 360, right? So 300 is between 270 and 360. 700 is bigger than 360, so you have to subtract 360. Then you get 340 degrees. Well, 340, again, falls in quadrant 4. Okay? 12 pi over 6. If you look at the fraction first, 12 and 6 cancels. That's just 2 pi. Well, 2 pi is one full rotation around, so it's on the positive x-axis. You can actually just say x-axis if you want, but do not give me a quadrant. Now, maybe you didn't notice that, and you wanted to convert 12 pi over 6 times 180 over pi, right? Your pi's cancel. 12 times 180 is 2160 divided by 6. Oh, that is 360. Right? And then you know, oh yeah, 360 degrees is one full time around. So you can leave it in degrees if you wish. That's fine. Okay. This one, let's just convert it. So 180 over pi. The pi's cancel. 180 times 10 is 1800 divided by 3 is 600. So this is really 600 degrees, which is not between 0 and 360. So I need to subtract 360. And then I get what? 240. And 240 is going to fall in quadrant 3. Okay? So that's review of that again. And you have your unit circle. I will give you this unit circle. So if you're not sure where it falls, look here. And then you can see, oh, this is 270. Oh, this is 180. It falls there. If you need to label this as quadrant 1, 2, 3, 4, right? Maybe you also want to say, hey, all positive, all students. So only sine is positive here. And only cosine, tan. And only cosine, right? All sines tan cos. I don't know, somewhere to remember that. Okay. You're going to want to use your unit circle to give exact answers. So this is what your homework was last night. Cosine is your x value. So you're going to go to your unit circle. You're going to at 0 degrees, right? You look at your x value. The coordinate there, since I don't have the unit circle in front of me, is 1, 0. So your x value is 1. Therefore, cosine 0 is 1. Could you put this in your calculator and get it? Yeah, sure, right? Just if it's a decimal, you don't want to do it. Okay, tan is y over x. You don't even need to worry about what mode your calculator is in, right? Because if you go to your unit circle, you go to 7 pi over 6 in that third quadrant, it won't have the x values on your test, but then you just go across to quadrant 1 and you can see your y value is 1/2. Your x value is root 3 over 2 in quadrant 1, right? So then that means in quadrant 3, x is negative and y is negative. And then when you're dividing by a fraction, that's when you keep, change, flip. So 1/2 times 2 over root 3. So this is really 1 over root 3, which algebra doesn't let us stay there. So I'd have to do root 3 over 3. And could you check this by putting it in your calculator? Sure. Your calculator's not in radians, so I wouldn't do tan 7 pi over 6. I would look at my unit circle and see, 7 pi over 6 is 210 degrees. So let me do tan 210, see what decimal I get, and check that that's what the other one is, okay? Secant, remember, is 1 over cosine, right? And cosine is x. So this is really 1 over x. So go to your unit circle, go to pi over 6. You see that pi over 6 is root 3 over 2, right? So now you have 1, you keep, change, flip. 1 times 2 over root 3. So 2 over root 3, rationalize, so multiply top and bottom by root 3, and then you're done. Okay, let's look at secant. Secant is 1 over sine. Well, sine is your y value. So I'm going to do 1 over. I'm going to look at my unit circle, go to pi over 2. I see my y value at pi over 2 is 1. So this is just 1 over 1, which is 1. If I was checking this on my calculator, I wouldn't put in 1 over sine pi over 2 because my calculator is in degrees. So I would do 1 over sine, go to pi over 2. I see that's 90 degrees. 1 over sine, 90, and I should get 1. Okay. Cosine, 3 pi over 4. Well, I know cosine is my x value. I go to my unit circle. 3 pi over 4 doesn't have the numbers, but I know it should be the same as it is in quadrant 1. So I know it is root 2 over 2, but I have to check, is the x value negative in that quadrant? Yes. So I should put a negative with it. I feel like something got left off here. Oh, am I zoomed in? Oh, I am zoomed in. Okay. So sorry, that was number 8. 7 is sine pi over 5 pi over 6. So remember, sine is your y value. And then if you go to 5 pi over 6 on your unit circle, it is in quadrant 2. And sine is my y value. So I'm looking at the y value in the other in quadrant 1, which is 1/2. And then I'm just double checking, is y positive in quadrant 2? And it is, so you're done. Tan 300 is in quadrant 4. Tan is y over x. So 300 degrees doesn't have the coordinates, but you get the coordinates. It has a denominator of 3. So you're going to look at pi over 3 in quadrant 1. And I see there that the y is root 3 over 2. The x is 1/2. In quadrant 4, where 300 lies, X is positive, Y is negative. So I'm also going to put a negative with that one. And then I have to remember how to divide fractions. Keep, change, flip. So this is just negative root 3. Okay? Cosecant is 1 over sine. Sine, remember, is y. So 1 over y. So if I go to 150 on my unit circle, I don't originally have those coordinates, but it has a denominator of 6. So I go to quadrant 1 that has a denominator of 6, and I look at the y value there, which is 1/2. So it's 1 over 1/2. Keep, change, flip. So it's 1 times 2 over 1. So that's just 2. Remember to check these on your calculator. Your calculator is in degree, but you can still do 1 divided by sine 150. Okay, make sure you're getting them. All right, last 4. Cotangent is the flip of tan. So rather than y over x, it's x over y. 3 pi over 4 is in quadrant 2. It has a denominator of 4. So you're looking at root 2 over 2 and root 2 over 2. Okay? Now, in quadrant 2, your x is negative, your y is positive. So these cancel, and you're just left with negative 1. Okay? Again, you can check on your calculator. Just type in, instead of 1 divided by tan, but instead of 3 pi over 4, you type in 135. You should get negative 1. All right? Tan is x over y, 270. So I go to 270, and those are the coordinates 0, negative 1. So x on top. Oh, sorry. Tan is y over x. I just did cotan, so I mixed it up. Y over x. So what's my y value? Negative 1. X value is 0. So that's not allowed. So that is undefined, right? You can't have a 0 in the denominator. Secant is 1 over cosine. Cosine is your x value. So I go to 225 on my unit circle, and it has a denominator of 4, right? 5 pi over 4. So those are the numbers again, root 2 over 2, root 2 over 2. So 1 over root 2 over 2. In quadrant 3, my x is negative. So I should put a negative with that as well. And then I do keep, change, flip. Keep, change, flip. Right? So negative, negative 2 over root 2. But rationalize the denominator, so negative 2 root 2 over 2. These cancel. So I just got negative root 2. It can get tricky doing these harder ones that have multiple steps with the radicals, so check it. Put in your calculator 1 divided by cosine 225 and see what number you get. Type in negative root 2. Make sure they match, okay? So now we're back to cotan, last one. X over y. So cotan 60. 60 degrees, my x value is 1/2. My y value is root 3 over 2. Because this is fractions, I need to keep, change, flip. So 1/2 times root 3 over 2. These cancel. Oh, this is in quadrant 1, so both x and y are positive, by the way. So I have 1 over root 3, which algebra says you cannot stay there. You must do root 3 over 3. Okay? I went fast. At any point, you could pause it and write your answers or try some on your own and just fast forward to check. So good luck. See me with questions.